Okay, so why I said case-based is that each organization has got a unique way of functioning. So you should design the infrastructure to suit the best in the best possible way to the functioning of your organization. Of course, you can take guidelines and suggestions from other similar institutions, but very rarely can you simply adopt a solution from somebody else's to your system. Even for software, you might be able to use somebody else's develop software developed by somebody else for yourself. But in this case, it is not possible. Infrastructure is completely different. And there are no standard solution available in infrastructure building. You have to understand your system. You have to understand your positives. You have to understand your limitations and then decide an infrastructure which you feel is the most suitable for the organization. And the biggest problem is if you make a mistake in understanding your requirements, then the next issue is you might spend money down the drains because what you build will never be what you want. And another thing I would like to say is infrastructure building and infrastructure management is one area where you can survive long in the industry, unlike coding, etc. There is an age to which you can remain a coder for your life. I would say maximum would be 30, 35. 30 is the proper age. 35, you can drag yourself on till that. By the time you'll be bored of coding. But network administration, database administration, project leader, project manager, these are designations which you can carry around longer and longer and longer. But if you look at infrastructure management, even you can take it further also. So those who want to shift their career after a certain specified amount of time in your life, it's always better to keep an eye on these areas so that whenever you feel that coding, of course, coding is good to a certain extent, right? After which, because coding, the problem is you are a part of a big organization. You cannot put all your creativity into that. That is why we normally get bored of the process. So at some point in time, you will have to switch your job profile. Keep this in mind because this is a safe zone. Not many people get into this, right? So it is it would be very good if you could really understand what we are talking about here, which is going to be practically useful. Even if you tomorrow you're not going to be a infrastructure person, but at some point in time, somebody will ask you, how can I set up a proper IT infrastructure for my organization? It could be your friend, it could be a relative, anybody. And you can even give suggestions as to uh, getting things done with the least possible expense. That is the most biggest important thing. Keeping the cost low, because if you start spending on technology, there is no end to it. You can keep on spending on technology. But the problem is keeping the cost low using minimal technology, but getting maximum output. That is something which you should always have in mind. And that is the basic and primary and the most challenging role of a technology guy also. I mean, infrastructure guy also. Now let us just start off with portions. Now, first, let us understand the 6 key components of IT infrastructure. One is the hardware, could be the desktops, the servers, etc., etc. So everything comes together. The software systems would be the operating systems, enterprise applications, mobile applications, etc., which runs on this infrastructure. The network devices, you know, uh, routers, firewalls, IPS, IDS, intrusion protect prevention and intrusion detection systems, load balancers, manageable switches, extenders, cabling infrastructure, etc. etc. Then comes storage, which takes care of the data, NAS, network attached storage, SAN, right? Then offsite storage in FTOs, etc. Then telecommunication and cooling infrastructure. So voice over IP, EPABX, IP phones, IoT devices, air conditioning, and power systems. All these are important part of everything is a part of IT infrastructure. Then comes your internet lines, branch office connectivity, client IPsec tunneling, etc. So these are the six key components of IT infrastructure. Any person who is going to work in IT infrastructure should have a clear idea about these six areas: hardware, software, network devices, storage systems, telecommunication and cooling infrastructure, and then finally the internet platforms. Because whenever you build an infrastructure today, you cannot avoid any one of these. All the six things are going to be present in your infrastructure, how much ever small it be today. Even a small shop has got connectivity. It might have two or three machines connected with each other. So network devices are there. It will have software, right? Then you definitely will have to keep a backup of that. So maybe you won't go for a so expensive device like NAS or SAN. Even maybe a small external hard disk for backup. But you should know what is available, how efficient it is, how effective it is, etc. Then comes telecommunication, which is voice over IP, PBX, iPhones, IP phones, IoT devices. Then air conditioning and power systems, which are very critical for keeping the system going. Then finally, the internet lines. What type of lines do you require? Whether you require dial-up lines, whether you require lease lines, right? So these kind of things also have to be considered for IT infrastructure. Okay, IT services. Now, IT services delivered to customers would be internal or external. Now, why do we say internal or external? One is today, every organization has got an IT department. Every employee working in the organization is actually taking services of the IT department, right? You take a hospital, you take a hotel, right? You take a big manufacturing company. Every organization has got an department called IT department or EDP department or whatever it is, who takes care of the infrastructure within the organization, making sure that it is running continuously without any fail. Now, IT services. Now, this is internal. Now, if you are an IT company itself, you are providing service for an external customer. You are providing help to an external organization in itself. So that is where you say internal or external. The process is the same, be it people inside the organization or be it people outside the organization. The method of providing service, if you look at the steps involved in how you provide service to people, is going to be the same. The only difference is some first set is within the organization, your own people, but the second set is your client, right? Now, IT infrastructure, vendor, customer relationship, internal or external customer, who provides the service, right? Example, email, desktop management, server maintenance, backup storage, network availability, firewall security, etc. Now, within the organization, your IT department will be taking care of all this. But if you're an organization, you might be one of the service providers. Say, for example, you might be looking only at the software part. There might be another set of people looking at the server and network infrastructure. There might be another set of people who are looking after the security, etc. Can include application development projects, maintenance, lifecycle management, creation, upgrade, and retirement. Delivered via well-defined SLA, service level agreements. Delivery mode on-site, remote. Offshore services such as remote infrastructure management. That is sitting in some place and then managing some companies' infrastructure. There are so many companies who have got offices in India and they what you call manufacture, support clients anywhere in the world, right? All that is done through remote mechanism. You might have already seen some small utilities which are available like TeamViewer, UltraViewer, etc., etc. Now, project versus process. You should clearly identify the difference between project versus process. A project is a unique and planned endeavor, has specific time frame, deadline to complete, not a continuing or ongoing activity like automobile production or help desk or service. So project is something which has got a deadline. It will be completed within the simulated time. It is not a continuous thing, right? You completed the project, finished with that, right? Requires a finite set of resources, including time and money. Every project is bound by limitations, and you have to plan properly to how much money, time, and resources you are going to utilize. Involves interdependent activities. So every activity of a project is normally interdependent. You cannot make it standalone. Has a high degree of uncertainty. The outcome of a project is always uncertain. How much ever you plan, how much ever you schedule things properly, you cannot guarantee that it will be over by this period of time, for example, right? And there is no guarantee that it will give you the solution you intended to get also. Now, to develop, deploy, or deliver a product or service to customer project. A complex, non-routine, one-time effort limited by time, budget, resources, and performance specifications designed to meet customer needs. These are the various aspects of project. Non-routine, one-time effort limited by time, budget, resources, and performance specs designed to meet the customer's needs. Now, just an illustration. That is project, routine, repetitive work. Projects, right? Say, for example, routine, repetitive work like taking class notes, daily entering sales receipts into the account ledger, responding to customer calls, writing a program for tax computation, manufacture of an Apple iPhone. Projects, writing a term paper, setting up a sales desk for a professional accounting, developing a customer support system, developing a tax management system, designing an iPhone that is approximately 2 into 4 inches, then interfaces with iWatch and stores 10,000 socks. So what you see on the right hand side is actually the project examples, and what you see on the left hand side is the routine, repetitive, what you call the process also. It keeps on happening in the organization. Now, IT infrastructure project. IT infrastructure project may encompass any or all of the following. One is application software development, could be full stack, front end, back end, middle tiers, etc. Hardware installation and configuration, servers, client workstations, devices, etc. Then hardware and software integration, network connectivity, LAN, WAN, etc. Storage/backup/ disaster recovery systems, deployment, performance tuning. Process versus method, methodology, life cycle, system, technique, and technology. Process, a well-defined and structured set of activities, like a methodology, framework, and the backbone of any development, project, maintenance, or service delivery. So that is called a process. A structured set of activities required to develop, say, a software system. That is called a process. Many significant software processes like waterfall, agile, DevOps, but all involve specification, design and implementation, validation, and evolution. Specification refers to defining what the system should do. Designing and implementation, define the organization of the system and implement the system. Validation, checking that it does what the customer wants. Evolution, changing the system in response to changing customer needs. A software process model is an abstract representation of a process. It presents a description of a process from one particular perspective, development or maintenance or service delivery, etc. Software engineering, a set of process models, the backbone of IT project management. Software engineering versus software quality management versus software project management. Software engineering, it's something which you've already gone through, versus software quality management versus software project management. Now, software quality management and software project management drive something called the software engineering. We use the term process, model, methodology, framework, all synonyms. Now, plan-driven versus agile processes. Now, earlier, what you used to have was you had certain standard procedures like waterfall model, which has got certain phases like project initiation, then analysis, then design, then development, then testing, and then finally implementation and maintenance. But nowadays, what happens is you don't have so much of time for completing a project, going through all these steps. That is where they came out with this agile principles, wherein you just start off working and everything like testing, etc. is done as you keep developing the project. There is no like you complete stage 1 and then go to stage 2, complete stage 2 and then go to stage 3. No, you don't have time for all that. You start developing and the moment you have finished a particular module, you test it and then implement it right away. If you can implement it, if it is not interdependent, if it is independent, you simply implement it right away. Now, waterfall versus process versus agile or scrum models. Plan-driven processes are processes where all the process activities are planned in advance and progress as measured against this plan. Example, waterfall, incremental, etc. In agile processes, planning is incremental and it is easier to change the process to reflect changing customer requirements. Example, Scrum. In practice, most practical processes include elements of both plan-driven and agile approach. There are no right and wrong software process. Remember that. Now, I can't go into detail of everything because we are actually short of time. So I'll just explain only the key points which are very critical in this thing. So always remember there is no right and wrong. If you design a process from your perspective, if it is right, it is right. A third person cannot come and say it is wrong. He can probably give suggestions, that's all. He can never say it is wrong because you have your own thought process which evolved into this idea, right? So there should be some justification for it, right? But if a third person feels that the approach taken is not proper, he can give suggestions, that's all. He cannot say that what you did is wrong, especially in this kind of process. Earliest model like I just now told you, used only for large, well-defined projects. For small projects, it was not feasible for those to do all this. So for well-defined product, you have requirements, design, system testing, implementation, verification, deployment, and maintenance. Now, agile methods, flexible and adaptive. Adaptive to changing or evolving customer requirements, agility, the ability to both create and respond to change in business environment. Rapid process versus agile frameworks. Being agile is equal to competitive, responsive, and flexible. Now, traditional projects, it is something like this. Fixed constraints, variable constraints. Fixed constraints is a scope, which is fixed, right? And variable constraint is one is cost, time, which actually reflects on quality. If you look at agile projects, it's the other way around. You have cost and time on top, quality, and then narrows down to scope. If you look at emerging technology and current technology, if you look at the growth and time, you can see that emerging technology always takes you much higher than the current technology if you are able to adapt it properly. So that flexibility your system should definitely have. Now, standards for IT development / maintenance. While adopted international de facto standards for frameworks, standards do not dictate choice of models, waterfall or agile. Software application development, maintenance models, etc. ISO 9001 standard, basic quality management system. ISO 20000 for IT services. CMMI developed DEV framework model for assessing software development maturity. Then IT service delivery models, ITIL framework, we'll come to that in detail later on. Then the capability maturity model, CMMI, SVC, right, which is related to service delivery. CMMI model tailored for IT services delivery. Then continuous improvement, Six Sigma, which is a Japanese, Japanese also has got something called the Kaizen, right, where they always try to do better than what they did yesterday. That is a culture of their life. Whereas in other countries, it is normally quality is a process which you have to implement and achieve quality. It's not a part of your culture. That is why Japanese quality is much more effective than quality control in any world, any organization. In Japan, they don't need quality department because everybody has got an inbuilt culture in themselves, which will take care of any issues that are there. Software lifecycle, choice of development models. Okay. Next question is software development, build or buy. Now, this is one big question that comes to any IT department. When they need some software, whether they should buy it or whether they should build it on themselves. Both have got equal number of challenges. Building on your own has got more challenges than buying a ready-made application. The only thing you must make sure is that what you buy is suitable for your organization. That's the only thing you have to look into. Because after you buy it, and if you're not getting what you want, then all the money that invested in this is going down the drains. Building versus buying software. The characteristics of project depends on the choice of process model, waterfall, prototyping and iterative approaches, incremental delivery. So waterfall model is, you might have already seen in software engineering, these aspects. What is waterfall model or why it is called a waterfall model? Then comes prototyping and iterative approaches. Finally, incremental delivery. You deliver the product in increments in-house. Often the methods to be used dictated by organizational standards, right? If you're doing it in-house, it is dictated by organizational standards. One example I can give you is you might not have all the possible tools to test each and every part of the software within the organization. Whereas if it is an IT company, who does it? They will have enough infrastructure where they can test the same software under different environments so that before delivering it to you, they make sure that it is. Then if it is a ready-made thing which you buy, then the advantage is it is already time tested. Many people have used it for a long time, and then based on that, they have modified it. And so the product that is now available in the market is more or less error-free, bug-free, right? And suitable. And most of them develop softwares in such a way that it can be fine-tuned to the requirement of the organization. SAP is the best example, SAP. SAP has been developed in such a way that every aspect of an organization function can be fine-tuned to the requirements of the organization. It's a challenge. Yes, definitely it is a challenge. It's not as easy as you think. But there are people who can help out. There are consultants who can help out to fine-tune SAP to the requirements of your organization. Now, in-house, often the methods to be used dictated by organizational standards. Then vendors need for tailoring as different customers have different needs. So if you're buying from a vendor, then you must have this concept of tailoring. Then agile methods, preferred choice for most organizations today, right? So the question is in-house development, build it. If you're outsourcing it, either get it built by an outsourced agency or buy it from a outside agency. Now, software development, built or buy. Pros and cons of off-the-shelf packages or products. Advantages. Cheaper, a supplier can spread development costs over a large number of customers. Software already exists and proven over a period of time. Now, that is one advantage. Can be used by potential customer. No delay while software is being developed because the product is already there. Maybe a little of fine tuning might be required, which can be done in a matter of a few weeks or maybe a 1 month, etc. And then you can right away put it. Whereas development will take a lot more time. And then you have to carry out a lot of tests on that, right, to make sure that it is functioning properly. Then even after that, when it starts working, it might pop up, come out with errors, etc., etc. So many issues related to all that. So here, if you're going for off the shelf, then there is no delay in software being developed. Where there have been mass of existing users, bugs are likely to have been found and fixed. Robust. Disadvantages. Customers will have same application as everyone else. No competitive advantage, but competitive advantage may come from the way an application is used. Now, if you're buying a supermarket software, the same software might be used by everybody. So being a software and all your information in that particular software, it is very important to get some data which will help you to increase your functional efficiency of the organization. If everybody is using the software, that means all the outputs are going to be the same. Everybody is going to follow the same principle, etc., etc., etc. So you will not get any competitive edge by using this particular software. Whereas if you have the software and you use it more efficiently. Of course, it is available with everybody, but not everybody is using it. Say, for example, software like Tally, etc. These softwares have got something called cash flow, fund flow, and all, which is normally used only by larger organizations. But even if a small shop tries to understand it and use that report to enhance its functioning, then definitely. So this is purely based on how the organization is using the software, nothing more than that, right? Then customer may need to change the way they work in order to fit in the off-the-shelf product. Sometimes that also happens. If you're going to buy ready-made software, you must modify it or you must modify yourself to fit the something like saying if you're buying a ready-made shirt, we all buy a ready-made shirt which is normally larger than the size. Because we know if we buy a larger one, we can alter it to a smaller one. Now, what happens if you buy a shorter one? Then the only way you can fit in is you have to reduce your fat. You become slightly thinner so that the shirt suits you. That is the only way you have out if you buy a shirt. So what happens sometimes there is a disadvantage also here. Sometimes you have to buy something which is more expensive than what you actually require and then fine tune it to your requirement. Use only those parts which you actually need, but still have to pay for what you don't use also. So those kind of issues are always there. Customer may need to change the way they work in order to fit that you are trying to fit the organization. A customer does not own the code and cannot change it. Now that is another challenge. When you buy off the shelf, if you buy, say for example, you buy Windows, can you change it? No, you cannot change it. Even if you know how to change it, even if you know how to make it more efficient, you cannot do anything because the source code is not available to you. So that is the limitation. The danger of over reliance on a single supplier. Once you buy a software ready-made, what happens is you are tied to that supplier. He will dictate terms. And what happens if he himself does it? He might give you 2-year warranty, 2-year support guarantee. But what happens if he himself closes down? What do you do? Nothing much you can do, right? The general guidelines of for the choice models. Okay. General guidelines for the choice of a model. Examine risks and uncertainties. Are requirements well understood? Now, that is very important. Whether you're going to get it done by somebody or whether you're going to buy it off the shelf or whether you're going to have an in-house team to do it, requirement analysis is very, very critical for development process because unless you understand the requirements of an organization completely, the product that you develop will not be useful to the organization. You will never get the desired results. So are requirements well understood? Are technologies to be used well understood, right? Then analyze the type of application being built. Is it an information system or embedded system? Criticality, differences between target and development environments. Customer specific requirements, if any, need to use a particular method, conform to industry specific standards. So analyze the type of application being built. Information system or embedded system. What type of system are you developing? What is the criticality? Differences between target and development environment. Customer specific requirements, if any, need to use a particular method. conform to industry specific standards also. Now, structured development versus speed, right? Structured development is what we call the standard procedures that were followed at a given point of time earlier. Now, as I told you, we don't have time, so we move to agile models. So the first one is called the heavyweight or formal or documented kind of development process. And the second one is lightweight, agile, and less documentation. Structured approach aka heavyweight models, step-by-step methods where each step and intermediate product is carefully defined. Emphasis on getting quality first time, doing it the right way. Example, use of UML in future adoption of model-driven architecture, MDA. UML supplemented with object constraint language. Press the button and application code generated from the UML/OCL model, then agile model for speed. Emphasis on speed of delivery rather than documentation, doing the smart way. Rapid application development emphasizes on rapid incremental and iterative prototyping, Scrum, extreme programming style. You might have come across this in software engineering if the paper is over, right? Now, waterfall model. Now, this is why it is called waterfall model. It comes down like a waterfall. So feasibility study. Feasibility study, user requirement, analysis, system design, program design, coding, testing, and operation. Now, if you look at the V model, you can see requirements, understanding requirements from here to here, which finally lands up in acceptance testing. Then comes specification, which is for system testing. Your system should match the specifications that were decided upon. Then architectural design, integration testing, how you put all these together. Then detailed design goes to unit testing, finally coding, right? And in many places, it is possible that it goes back to the previous stage, primarily because you understand the requirement, come across a specification. But when you actually again look at it, you might feel that you have missed out on something. So you go back and analyze the requirements once again. Same with architectural design also. You go back and redesign, rework on your specification. Because it is very difficult for you to find out all aspects of the software at the first go itself. Now, imposes waterfall or the classical model, what you call it, imposes structure on the project. So it has to go through these steps itself, no other alternative. Every stage needs to be checked and signed off. So after each stage, checked, and then finally it is passed on to the next stage. Inflexible for changing customer requirements or when requirements are not clear at the beginning of the project. Limited scope for iterative development. Since every stage is clearly defined and you close it after that, iterative development may not be. Iterative basically means repeating kind of development. It may not be possible in this kind of a system. It is quite possible that if you follow iterative in this, then you will have to rework or your work will be double the work that you normally have to produce large amounts of documentation, which can be largely under. So there is another issue with waterfall model. You might land up with so many, what you call documentation, which nobody will actually read. Users are excluded from the decision process. Now, nowhere you will see that the user is involved in the development. That is, the person who is going to use the software that you develop is never involved in the decision-making process. Now, today, most importance that is given is the user involvement. From stage one itself, the person who is going to use the software will be a part of your development team. Because if there is anything out of the way happening, he will be able to guide you, saying that this is not I wanted or this is not what is intended, etc. So that you don't have to develop the whole thing and then finally to tell the customer and then he comes with a change and then you go back and rework, etc., etc. Now that is actually a reason for the development of a lot of unreliable software. Changing it continuously without any control. Users are excluded from the decision process. Then long lead times to deliver anything tangible, because we are very stringent with the steps involved. Then it will take us a lot of time to deliver something which is tangible. V model approach is an extension of waterfall model where testing phases are identified parallel to the development phases. See here, you can see at each stage there is testing here: coding, detailed design, unit testing, architectural design, integration testing, specification, system testing, and requirements acceptance testing. Okay, now coming to incremental model. Now, incremental development, but still structured and formal. Incremental basically means you divide your whole big project into small independent modules and then start making each one of them and keep delivering it to the customer. Each one should be functional. Only then you can deliver it to the customer. And we have an incremental delivery plan where you identify system objectives, create open technology plan increments, right? Then repeat for each increment: design increment, build the increment, implement the increment, evaluate the result, give feedback, and then go back to the. So this keeps on repeating until the project is over. Planning of requirement is incremental, but development model is still structured, follow waterfall. Each increment or step is ideally 1% to 5% of the total project, typically less than a month, but not more than 3 months. So that is the time frame they decide for incremental model. Each step should deliver some benefit, intermediate deliverable to the user. It is not that there is going to be a model which is not primarily making any difference for the user. That also cannot happen. Feedback from early stages used in developing later stages. So at each stage, you take the feedback received from the previous thing to this part. Manage risk better. Drop project altogether at any stage if costs schedules become unmanageable. That also something which you can do. Manage risk better. Drop project altogether at any stage if cost or schedule. Because many times what happens is in the beginning, you may not be able to understand the complete scenario of the project. It is only sometimes what happens is only after 25% of the work is done, you will feel that it is not feasible for you to go ahead with the project. Maybe technical, maybe financial, or maybe any reason for that matter. You cannot move forward. So what happens is it is okay if you drop the project completely at that stage also, thereby reducing further damage. Now, agile methods, way to go to it. Time boxed development with visible deliveries at frequent intervals, right? Now, time box deadline by which something has to be delivered, typically 2 to 6 weeks, known as sprint. So you fix a period and then you make it a deadline and something has to be delivered in that specific deadline. That is why it's called sprint. Prioritize requirements at each iteration, that is sprint. Each requirement has to be prioritized, and the most important ones are to be done first. Moscow priority, what you call must have, should have, could have, want, right? Must have means essential. You cannot compromise on that. Most highest level of priority. Should have, very important, but system could operate without. So not very critical, but still could have. It was better if we could have that kind of an approach. Not necessary, not should have also. Then want, but probably won't get. So some things which you want, but may not be possible for us to implement. Agile methods, Scrum, extreme programming, paired programming, lean, Kanban, etc. These are all methods which are used nowadays, out of which Scrum, I would say, is the most popular one. So agile methods are used to develop products very fast compared to the traditional old models. Now, waterfall versus incremental versus agile, evolutionary versus iterative prototype. If uncertainty is high, then use evolutionary approach agile, right? If complexity is high, but unnecessarily uncertainty is not, then use incremental approach, structured but manageable increments. If uncertainty and complexity are both low, then use waterfall model, structured, heavyweight. If schedule is tight, then use evolutionary or incremental agile. So these are the various approach that you have to take in various situations. If uncertainty, then go for evolutionary approach. Take your own time. If complexity is high but uncertainty is not, then use incremental approach, stage by stage. If uncertainty and complexity are both low, then go for structured or heavyweight mode. If schedule is tight, then use evolutionary or incremental agile. Now, agile methods, the motivation and benefits. Give me a second. Okay, now we move on to agile methods, the motivation and benefits, purely going into agile methods. Now, software development challenges. Traditional software projects. In 2009, companies and organizations in US spent $491.2 billion on application development. That means that more than 103 billion was wasted on failed projects. Now, 46% challenged functionality and quality over budget, time overruns. So in 46% of the cases, functionality and quality was not as expected. Then it went beyond budget, and then it took more time to develop, which ultimately brought a loss to the project. 19% was cancelled for various reasons, and only 35% was successful, on time, on budget. Right now, features and functions used in typical system. Now, 45% of the features were never used. 7% was always used. 13 often. 16 sometimes. 19 rarely. So just look at it. If you take a software, please understand that only 7% of that is always used. And maybe you can consider these two also. 13% plus 16%. So give more importance to this as these three aspects. Most importance to this one, that is 7% of always, often 13%, and then sometimes 16%. Give lesser importance to these two categories. Never used, just forget it. Rarely used, 19%. You cannot do without it all. Now, addressing challenges of waterfall model. Now, waterfall or agile transformation. Traditional waterfall or adaptations of waterfall, incremental iterative prototyping, focus on requirements management, breaking down into manageable increments, de-risking large development effort, capturing requirements, show and tell, prototype as basis of discussion and around requirements, quick and dirty working prototype to start with. So waterfall, incremental and prototype. So waterfall model to agile transformation. Traditional waterfall adaptations of waterfall like incremental, iterative prototyping, etc. Focus on requirements management, breaking down into manageable increments. Then de-risking large development effort, right? Try to reduce the risk of projects which take a large development effort. Do proper planning, set proper milestones, and make sure that you can curtail the cost of development process as much as possible. Because that is where people become careless or not so mindful about doing it and finally land up in huge issues, which can lead to cancellation of the project or even abandoning the project. In capturing requirements, show and tell, prototype as a basis of discussion around requirements. Then you have something called the quick and dirty working prototypes to start with. So you have the waterfall model, Now this is the incremental model and this is the prototyping model. So initiation, then you go around analysis and planning, then build and design, testing, deployment, review. Cost and complexity keeps increasing as you move outer to the outer stages. Agile is a savior. Agile turns upside down project constraints. And that is why most of the companies today follow agile models. Of course, it is not pure agile, which actually started off. It is kind of a mix of all put together, right? Depending on how best you can fine tune your process model. So agile turns upside down project constraints. Now, always there are some fixed constraints and variable constraints, as we saw earlier. Traditional projects, the scope is the fixed constraint, and then cost and time is something which is in your hands. So how can you keep the cost low within the stipulated time and still maintain quality? In agile projects, you start off with the fixed constraints with the cost and time is fixed. Time is fixed here. That is the most important thing. They say so much and so much of resources are allocated for you. Finish with that. Within that, you have to maintain your quality. And then it slowly comes down to the scope of the project. Agile development, a series of short sprints. If you look at traditional waterfall model, you can see requirements, design, development, testing, deploy, etc. Here, what happens is each one is a sprint in its own. Requirements, then demo and feedback. In between, you have design, test, integrate, test, develop, test, so on. Now, highest priority, high priority features, medium priority features, low priority features, optional priority features. So you keep developing the project based on these factors. One is the highest priority is done first, then the high priority, then the medium priority, then the lower priority, and finally the optional priority, stage by stage. Now, agile development, which is equal to iterative releases. Working software at any stage. Agile software development is a conceptual framework for software engineering that promotes development iterations throughout the life cycle of the project. Software development or software developed during one unit of time is referred to as an iteration sprint. Now here in the previous diagram, we saw this is one sprint, right? Which may last from 1 to 4 weeks because that process has to be completed as such. Then you have agile methods, which also emphasize working software as a primary measure of progress. Agile helps de-risking upfront cost. If you look at entrepreneur startup, they love agile. One is fail safe earlier than failure at the end, right? That means if there are issues, since you are developing everything as sprints, independent modules, you can test it and get results immediately. Then the proof of concept when adopting new technology. Testing the waters before launching big in the marketplace. Now, today's software products are strategic levers, idea-driven rather than mere automation of manual process. So there is a huge change in way which the projects have changed over a period of time. Earlier, people were thinking more about automating the process to make the job of the human beings easier. But nowadays, most projects are new ideas concept completely, which have never existed probably, right? And you're developing software for that. Now, control development. Agile products are based on empirical control method, decisions based on reality, touch, feel, and design. Now, adjustments on the go by frequent inspections, transparency, everyone involved knows what is going on in the project, frequent inspection, regular evaluation of the product, adaptation, make quick adjustments to minimize problems later. So transparency, everyone involved knows what is going on in the project, frequent inspection, regular evaluation of the product, adaptation, make quick adjustments to minimize problems later. Now, project management driven by agile methods. Traditional project management turned upside down. We saw it the 2 slides back. This is the one. Let's wait till the project completes to see the product. Several mini projects with little visible success. Then transformation of project management is actively involving all the stakeholders, organization structures and communication, time boxing of delivery, fixing time. That is very important everywhere. You must have a clear idea about when you will deliver. If it is 3 weeks, 3 weeks, try to finish it off within 3 weeks. But if you don't keep the deadline of 3 weeks, the tendency of taking more time is by default always there. Now, Standish Group study on software project success and failure in 2009 said 26% of the projects failed outright, but in 2011, that number fell by 5%. The decrease in failure has in part been attributed to wider adoption of agile approaches. Benefits of agile project management. No surprises at the end of the project because each stage is small. You keep monitoring it heavily. So what happens is, unlike the old traditional project of waterfall model where you don't know what you're doing sometimes, and it's a huge team working on each phase after phase after phase. So predicting output becomes very, very difficult. But in this case, in agile project management, there are no surprises at the end of the project. So almost zero risk of catastrophic project failure, prioritization of business value over good or nice to have features, agile testing, continuous testing ensures problems are discovered early, then downplays scope hyphen creep as requirement changes are managed throughout the product development lifecycle, prioritizing features in early iterations and managing evolving requirements. Continuous inspection and adaptation, improvement of processes and products based on prior experience of the completed product. These are things which we have already discussed. Now, agile method summary. Agile is a great leap forward compared to the older ways of developing. Those who have seen, personally, I have all seen the older phase stages of it, but that in those days, the problem was computerization was not all over. People were ready to accept time frames, longer time frames. And then many times what used to happen was the user didn't know what is happening because he was never involved in the project and he didn't have any knowledge about technology. And on the other hand, you had people who were into technology, but many times did not have any idea about what the user wanted. So in the interaction itself, a lot of time used to go waste. So everybody, because it was not so critical in those days, everybody accepted the fact that this will take time. Today, that is not the scenario. Everybody knows technology. Everybody knows what they want. Everybody knows what is possible and what is impossible. So looking at that, agile is definitely a huge game changer for development. Traditional software development methods involve large online projects are yielding to low risk, high turnaround incremental deliverables in agile methods. Involvement of all stakeholders, including customer, early in the process enhances collaboration and minimizes scope creep. So this is from the beginning itself, the user is involved. So what happens is user is kept updated about what is happening. So that if anywhere he feels that this is not what we want, he can immediately move on and change over. Full transparency and high visibility of deliverables in short iterations, sprints. Continuous quality monitoring with embedded agile testing across iterations. Agile is the great leap forward in software development methodology and with its associated transformation in agile project management. So Agile is a great leap forward in software development methodology with its associated transformation in Agile project management. Now, overview of Agile methods, Scrum framework, XP or extreme programming or pair programming. Now, common Agile methods, Scrum framework, extreme programming XP model, pair programming model, dynamic system development method, feature-driven development, and rational unified process, RUP. Agile, Scrum, Crystal, Kanban, XP, DSTM, FTD, RUP, etc. Now, Agile methods review. Iterative and incremental approaches, risk-driven and client-driven approaches, time box development, adaptive and evolutionary development. Now, we are going to try something called Agile programming. That means no more planning and no more documentation, just start writing code and applying. I'm glad it has a name. Now, what that was your training. Now, everybody has got their own way of looking at Agile method also. Customer risks, requirements, hard to get. Ours is a world where people don't know what they want and are willing to go through hell to get it. So, as I told you earlier, when a technology guy meets a user, the biggest gap that we find is the technology guy is not aware of what the user is using or what he is doing, etc. And the user is not probably updated of technology. Things have changed over a period of time, definitely. Yes, today an ordinary user is also well versed with what you call technology. So these things are there. Requirements are capabilities and conditions to which the system and more broadly the project must conform, kind of. A prime challenge of requirement analysis is to find, communicate, and remember. That usually means write down what is really needed in a form that clearly speaks to the client and development team members. More than 50% of the requirement keep changing through the development cycle, particularly true while working with Oriental customers like Japanese. Waterfall is a nightmare. Don't go for it. As on date, waterfall is a nightmare. You cannot manage it at all in today's environment, today's scenario. So nobody opts for waterfall model. You may see waterfall behavior in Agile methodology, but that is completely different because it's all time bound and framed. Requirement change, project size and function points. Now, iterative versus incremental is the way to go. You should use iterative development only on projects that you want to succeed. Martin Fowler. Early programming and testing of partial systems in repeating cycles in Agile versus iterative model. Early upfront speculative requirements freeze before programming in waterfall models. Refinement of systems through successive fixed length iterations, mini projects or sprints. Common Agile processes are Scrum, Lean Development Unified Process, Test Development Process TDD, Feature Development Driven Development, and then Adaptive Software Development. Now, these are various models. So Scrum, Extreme Programming, DSTM, which is then feature development, and then finally, there are many more to it. Now, sprint, and finish. Iteration sprints converge to true requirement. No waterfall thinking in iterative development. On an average, 45% of the feature in waterfall model are never used. And every early waterfall model schedules and estimates vary up to 400% from final actuals. Early iterations are further from the true path of the system via feedbacks and adaptation. The system converges towards the most appropriate requirements and design. In late iterations, a significant change in requirement is rare, but can occur. Such late changes may give an organization a competitive business advantage. So if you look at it, one iteration of a design implement, and integrate. The early iterations are further from the true path of the system. Via feedback and adaptation, the system converges towards the most appropriate requirements of the design. In late iterations, a significant change in requirements are rare, but can occur. Much late changes may give an organization a competitive business advantage. Agile, risk-driven, customer-driven, iterative planning. On the choice of requirements set for each sprint, early iterations with highest risk ensure early visibility of key features, focus on stabilizing architectural choices. Now, spiral model starts here. It moves on to, slowly it moves on to construction, then deployment, communication, planning, right? Again, construction, deployment. So this keeps repeating. That is called the iterative approach, right? And it is also a risk-driven approach because you're taking a huge risk in carrying out the development process because you're doing it fast. Unlike the traditional models like waterfall, etc., where you had enough time. Now that is also there. Today, using waterfall model is itself is a huge risk. Now, what is an iteration for a sprint? An iteration includes well-defined prioritized set of requirements, time box schedule, deadline. So one is the requirements are clearly defined, and the second is it is time boxed, it is fixed, deadline is fixed. Output deliverable, tested, integrated, and partial usable system. So that should be the output deliverable for a sprint. Then each iteration includes its own requirements, analysis, design, programming, and testing cycles, mini what. Incorporates feedback from customer and other key stakeholders after every iteration. Now, Agile, continuous feedback is the key. So in Agile model, since you are doing things very fast, you need to have continuous feedback to make sure that you are not making any mistake because it's a fast development process. So even the mistakes you make are going to be fast. And then going and changing it might be very, very, very difficult, right? So the time boxed iteration with feedback is like requirements, design, implementation and test, and integration and more design, final integration and system test takes almost 3 weeks. Then time period allowed, after which again the next stage starts and so on. Now iterations are fixed in length or time boxed. Feedback from iteration n leads to refinement and adaptation of requirements and design in iteration n+1. That means whatever feedback you get at the first at n level will be an input which will help you to refine the next stage, which is sequentially called n+1 to give a better output. Now, most common agile frameworks. Scrum framework, extreme programming, XP model, then pair programming model. Pair programming model is basically two people sitting and doing the same code, right? So that finally what happens is you merge these two to get the final good output. You take inputs from both and then finally do it. Common framework methods are techniques in practice that embrace characteristics of agile. Lean software development, which is called Kanban. Then extreme programming, XP, Scrum, widely adopted today. Common principles that govern the agile framework is one is iterative development by multiple iterations, simplicity, transparency, and situational strategies, being street smart for rubber meets the road challenges, then cross-functional, self-organizing teams, visible progress measured by working software at any instant. Project switch agile framework, defining structure versus being prescriptive. Project adopting lean methods in Scrum focus on well-defined structures and roles. Extreme programming, XP, requires a technique like pair programming, release planning game, and test-driven development, etc. are more prescriptive in nature than project activities. While Scrum is the most popular method practiced in organizations, Individual developers slash entrepreneurial setups adopt a creative combination of the methods to meet the project challenges. So we have Scrum framework, Kanban framework, lean software development, extreme programming, crystal development framework, dynamic system development, feature development, lean methods, inspiration from agile. So there again, what lean basically means, you are trying to fine tune agile method even more. Lean, eliminate wastage, just in time, and ownership by the shop floor worker. Originated in Japanese manufacturing organizations, Toyota's Kanban system. Lean methods focus on eliminating wastage in mass manufacturing process, just-in-time production system. Focus on humans in the decision making and production process versus expensive machines. Ownership by shop floor workers versus supervisors and managers. Then optimize the whole, build quality, learn constantly, deliver fast, engage everyone, continuous improvement, which is called case. These are all principles of lean methods. Lean applied to software product development. Avoid unnecessary features. People, not machines, are central to project. They add real value. Involve customers early on to prioritize requirement. That is what we have been discussing now. Customer should be involved in the project as early as possible. Earlier, that was not the case. Customer would see the product only after it was developed. Constant communication among all stakeholders using proper tools. Now, extreme, nothing extreme, but undivided focus on customer throughout the project. That's called extreme programming. Guiding spirit, extreme focus on customer and projects like war rooms. Features to be developed when customer needs them. New features or change requests accepted as part of daily routine. Dynamic self-organization of teams around customer problems or issues as and when they surface. Principle of XP. Coding is the language of product and communication. Extensive testing. Then coding doesn't start unless success criteria is defined. A bug is not a failure of code, it's a failure to define the right test. Then direct communication between programmer and customer. Design during refactoring and reduce complexity and maintenance. So on one hand, you can see the whole idea is to develop it as fast as possible using the minimum resources with minimum cost. And on the other side, you are trying to give as much quality as possible, right? So that is the whole idea about the first module of. So we are done for the day. Thank you so much. I know I'm moving fast, but there is no alternative. We have to finish a lot of portions. Quiz will be available only from the next class, okay? Thank you. Yeah, I'll share the PPT. Actually, this has to be updated slightly more. So as soon as that is done, I'll keep sending you PPTs after the class.